a summary of muscle contraction. Need me to say it again? Oh, look at me. Okay, action potential travels down the nerve. That causes the release of the acetylcholine. Acetylcholine crosses the cleft, attaches to the receptors. The receptor gates open, sodium rushes in. That will begin to affect the voltage gated, so we begin to have the voltage change. This excites or sends messages, sends information through these T-tubules. We get into the sarcoplasmic reticulum. Sarcoplasmic reticulum will release the calcium. Calcium will bind to the troponin. Troponin will make the tropomyosin shift. Active sites will be available. If active sites are available and energy is present, myosin heads can attach. They can release, they can attach again, they can release, they can attach again. Each time sliding that actin filament closer to the M line, okay? And it will continue to do that until calcium moves back into the sarcoplasmic reticulum. See how easy that is? Now, if muscle contracts, we got to make sure it relaxes. So in the relaxation, what we're going to see is that the calcium moves back into the sarcoplasmic reticulum. It has to go back by way of active transport. All right, so we need a little bit of energy. Calcium moves away from that troponin-tropomyosin complex. The tropomyosin shifts back over those active sites. The myosin heads can simply go back into their cocked position. And at that point, what do they have attached to them? ATP or ADP plus inorganic phosphate?
ADP.
The ADP plus the inorganic phosphate. Because the ATP is what will make them release from the active site. What you think? Ever thought about your muscle contraction at this level? Tell me it's not a cool process. Good, because it's a cool process. So how is it that we're going to get an entire muscle to contract? We see what it takes at that functional unit area. And the functional unit of muscle is what? Sarcomere. But we got to see if an entire contraction can occur. We can measure this, right? Because we can do a myogram, okay? We're gonna term one cycle of a contraction and a relaxation a muscle twitch. And I don't just mean, okay? Because you think of muscle twitch, you guys probably think, right? That's muscle movement. That means an entire muscle set moved, okay? So, the muscle twitch, we look at this based upon what occurs in the one cell, and that one cell is indicative of what takes place for the entire fascicle, the entire grouping, the entire muscle. All right, because every single fiber is going to have its end, that terminal end from the nerve, innervate the fiber. Okay? So, the muscle twitch is one contraction and relaxation cycle. So if that happens to all those different fibers that are present, that means most likely it's strong enough. And if it's strong enough and it reaches threshold, what was threshold? We got to get it.
Negative 85? Or was that the
Well,
relaxation?
they're resting somewhere around the negative 85,
It was negative 35?
roughly about negative 35. Okay, so we've got to make the interior less negative, okay, inside that membrane. And if we reach threshold, the muscle, that fiber, and if it's occurring to all the fibers, the muscle will contract no matter what. So, we'll have a stimulus. The stimulus causes an action potential from the nerve. The nerve innervates more than just one muscle fiber. When a single contraction and excitation, when we have well, let's do the contraction relaxation. When one entire cycle takes place, these are the phases that occur. So for every contraction, relaxation phase, these are the phases that will take place. We have the lag phase, the contraction phase, the relaxation phase. The lag time. This is the time between the stimulus and that motor neuron that begins the contraction. Contraction phase, exactly like the name implies. We've passed threshold and it's going to contract no matter what. Relaxation, like the term implies, the time that calcium moves back into the sarcoplasmic reticulum. What do you notice about this chart right here? It takes longer to relax than it does to contract, and it takes longer to contract than it does for the lag. This event that takes place for this muscle twitch, for this cycle of the contraction and the relaxation, this is an electrochemical event. Why do we term it electrochemical? What's the electric part?
Action potential.
And the action potential is, what are we doing to the pluses and the minuses? We're flip-flopping them, right? Okay? That's our electrical portion. What's the chemical portion? The acetylcholine. All right? So this is an electrochemical event. Doesn't take a lot of time from the point of that stimulus to that motor plate. From the time we get to the motor plate and contraction taking place, that's a little more time needed. There's a lot of time required for relaxation. Any idea why? We've got to take it back to being more negative. Energy is required. Energy is required at the time of the contraction, and energy is required for the relaxation, because it does require active transport to get that calcium back into the reticulum. But in the grand scheme of things, how quickly does a contraction take place? Quickly. Milliseconds. I mean, I don't know about you guys, but when we look at milliseconds, there could be, based on how quickly the skeletal muscle works, 500 twitches in a second. Because it's milliseconds. That's huge, okay? That's a lot of action potential. That's a lot of contraction relaxation taking place. So, this action potential, it's going to make it to that motor unit, and what we want it to do, if it is required, if it's a movement that's needed, we want it to recruit. So if that action potential travels down that nerve to the end, and at one end, do you remember how that was termed a motor end plate? Okay, and that's a motor unit because we're looking at it doing something, okay, some type of movement. What we want it to do is recruit as many of these neuromuscular junctions as possible. Because if it can recruit this one, if it can recruit that one, if it can recruit this one, and 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 this one, we're going to get a contraction, right? Yes. So, these motor units, when we talk about a motor unit, in the large muscles of the body, motor units are going to have a lot of fibers. In the small muscles, not as many, because there's not as many fibers to innervate. So if we think about this movement, large muscles, correct? In reality, how am I making that occur? I'm thinking about it. That starts my action potential. And my body is going to respond because in that plasma membrane of the muscles, I'm going to have them have electric charge, and they will be ready to make this movement. But in making the movement, what's happening is it's got to go through the contraction, relaxation, contraction, relaxation, contraction, relaxation, contraction, relaxation, contraction. Do you get my drift? Okay? Because if it didn't, okay, if it didn't go through contraction and relaxation, it would just simply be, right? So I have to make sure that I have the contraction relaxation. And to make that entire muscle do what I'm wanting it to do, okay, I have recruited a lot of motor units in these bigger muscles of my body for movement. But if I'm simply doing